Let's try solving a linear system by substitution. Now you know you don't want to solve for this y. You don't want to divide by 5 and play with fractions. Don't divide by 3 and play with fractions. There is the little guy. Let's pick on the little guy. Let's take that first equation. And we're going to solve for this x because it's the only variable with a coefficient of 1 or -1. Okay, so I want that x all alone. I will get that x alone if I move this 3y to the other side using addition. So we find, even though we don't know if x is 10 or 2, that x is 3y plus 3. What are we going to do with it? We're going to plug it into the other equation. It's got to go into the other equation or we make the wrong conclusion. Let's get to it. We'll take that 3y plus 3, put it in x's spot. Then the second equation becomes 3 times 3y plus 3 instead of 3 times x, plus 5y equals -19. The good thing about that is now we have one equation with only one unknown. We'll distribute 3 times 3y, 3 times 3, add 5y, combine our like terms, that's 14y plus 9 equals -19. We want to solve for y. Let's move that 9 away with subtraction. We end up with 14y is equal to -28. We'll divide by 14. We find that y is -2. But then there's the question. Well, if y is -2, what's x? To find out, we'll plug into either of the original equations. At the start, we had x minus 3y is 3. We also had 3x plus 5y is -19. And we'll take that -2 and put it in for y. So that is x minus 3 times -2 equals 3. That's x plus 6 equals 3. Move 6 to the other side with subtraction. In the end, we find that x is -3. We've known that y is -2, so our solution as an ordered pair in order is -3, -2. That is one solution, and this system is said to be independent.